Welcome back to Key Safety Talks, everyone.
It's good to be back.
Today, we're going to be diving into something that affects, really all of us, whether we're safety professionals or just trying to get through life without, breaking a leg.
Or worse.
Or worse, exactly.
Yeah.
We're talking about hazard control.
And we're going to be sort of weaving in this idea that you've probably heard of, Murphy's Law.
Oh, yeah.
Anything that can go wrong will go wrong.
Yeah, that's a familiar one.
But instead of kind of, going down that doom and gloom path, we want to talk about, how understanding Murphy's Law can actually make you safer.
Right. So it's not about being afraid. It's about being prepared.
Exactly.
It's about understanding those curveballs life throws at you and maybe even catching a few.
Catching a few, yeah.
So where do we even begin with something like hazard control? What is a hazard anyway?
Well, in the simplest terms, a hazard is anything that has the potential to cause harm.
Harm.
So that could be...
That could be an injury, it could be an accident, property damage, even a near miss. So it's not just about those big, obvious dangers.
Right.
It could be something as simple as, loose rug on the floor, a cluttered stairway,
Yeah.
or even bad lighting.
Hazards can be sneaky.
Yeah, they really can.
They can hide in plain sight. And that's why hazard control isn't just about reacting to problems.
Yeah.
It's about planning ahead, designing things with safety in mind and minimizing those risks before something bad happens.
I love that. It's about being proactive, not paranoid.
Exactly.
So it's like that old saying, an ounce of prevention is worth a pound of cure.
Exactly.
And I know there's this framework for thinking about hazard control called the hierarchy of controls.
Yes.
Could you walk me through that?
So imagine a pyramid. At the very top, the most effective way to deal with a hazard is elimination.
So just get rid of the hazard entirely. Problem solved.
Yeah, if you can.
If you can.
Mm.
But I'm guessing that's not always possible.
You're right.
Like, what about driving a car?
Yeah, you can't eliminate the hazard of a crash entirely.
Right.
But you can reduce the risk, and that's the next level down on the hierarchy.
So if you can't eliminate it, you try to minimize it as much as possible.
Yeah.
So like in the car example, we wear seatbelts, we have airbags, we drive the speed limit, we stay alert.
All those things.
All of those things to reduce the risk of an accident.
Exactly.
So what comes next on the pyramid?
Next are safety devices.
Okay.
These are things that are specifically designed to protect you if something goes wrong.
Okay.
Think about machine guards on power tools or the safety features on a roller coaster.
Right. Those are like the guardians that step in when things go awry.
Exactly. And then we have warnings.
Right.
Things like signs, alarms, labels.
Okay.
They're important, but they rely on humans noticing and reacting correctly.
Right.
Which isn't always a guarantee.
It's not. Yeah. Sometimes we're distracted or we miss those warning signs.
Yeah.
It makes me think of those like caution hot signs you see on coffee cups.
Right.
How many times do people still burn themselves despite the warning?
More than we'd like to admit.
Probably.
And that brings us to the bottom of the hierarchy procedures and personal protective equipment, or PPE.
PPE.
So these are like the last line of defense.
The last line of defense.
Procedures are the set steps you follow to minimize risk, like standard operating procedures in a factory or even a recipe when you're cooking.
Right.
And PPE is all about creating a barrier between you and the hazards, like wearing gloves when you're handling chemicals.
So we've got this pyramid with eliminating the hazard at the top and PPE at the bottom.
Yeah.
Does that mean we should always aim for the top of the pyramid no matter what?
Ideally, yes.
Okay.
But there's a catch.
Uh-oh.
We need to balance effectiveness with practicality and cost.
Right, because sometimes eliminating a hazard is just not feasible.
Right.
Or it's just way too expensive.
It could be.
And sometimes the controls we put in place can actually create new hazards.
Absolutely. It's like a game of whack-a-mole.
It is.
You solve one problem and another one pops up somewhere else.
Yeah, exactly. Can you give me an example of that?
Sure. Let's say a company replaces a hazardous chemical with a supposedly safer alternative.
Okay.
But this new chemical, while less toxic, is also more flammable.
Oh, so they reduced one risk but introduced a new one.
Exactly. It's crucial to think holistically and consider those ripple effects of our choices.
That makes a lot of sense.
Yeah.
But there's something else we haven't talked about yet, the human element.
Right.
We've mentioned human error a few times.
Yeah.
And this is where Murphy's Law really comes into play, right?
Absolutely. Even with the best safety systems, human behavior can be unpredictable.
Yeah. Humans are the wild card.
They are. And that phrase, if anything can go wrong, it will. It didn't just appear out of thin air.
Right.
It came from a real life incident.
Wait, there's a story behind Murphy's Law. I always thought it was just, pessimistic saying.
There is. So back in the 1940s, there was this Air Force engineer named Captain Ed Murphy,
Okay.
and he was working on a project testing human tolerance to G-forces
Oh, wow.
using a rocket sled.
A rocket sled. Sounds intense.
It was. They were basically strapping people into this thing and blasting them down a track to see how much their bodies could handle.
Wow.
But during one test, a technician wired the sensors incorrectly, and the test failed miserably.
That's a pretty major mistake.
It was a big one. And it was this incident that prompted Murphy to utter that now famous phrase, "If there are any ways to do it wrong, he'll find them."
Wow. So that's where it all began.
It is.
But it's more than just a funny story, isn't it?
Right.
It's a reminder that even in controlled environments, human error can still happen.
Exactly.
And Murphy's Law has a whole bunch of corollaries that further emphasize this point.
Right.
Like, nothing is as easy as it looks.
Yeah.
Every solution breeds new problems.
Uh-huh.
And perhaps most importantly, left to themselves, things tend to go from bad to worse.
Yeah.
These are pretty insightful.
Yeah.
And a bit unsettling, if I'm being honest.
Yeah.
But I guess it's better to be aware of these tendencies than to bury our heads in the sand.
Absolutely. And it's why we need to factor that human element into all our safety planning.
Right.
We need to design systems that are as foolproof as possible.
Yeah.
Anticipate those potential errors and create a culture where it's safe to report mistakes without fear of blame.
That makes a lot of sense. So we've got this framework for controlling hazards, and we're keeping Murphy's Law in mind to remind us that, things can and do go wrong.
Right.
But are there any real-world examples of how these principles have been applied? Or perhaps more importantly, where they haven't been applied effectively?
Oh, absolutely. There are tons of examples, both good and bad. And I think it's through examining these real-world cases that we can really start to see the importance of hazard control.
Okay, I'm all ears. Hit me with an example.
Well, let's take a look at case 9-2 from our source material.
Okay.
This one involves a mishap during the installation of some seating units.
Okay, what happened in this case?
So some workers were installing seating units in a building, and the instructions they were given were very vague. They didn't specify how the unit should be attached to the wall or the types of fasteners to use.
I'm already sensing a problem.
Right.
Right? And in this case, the installer made some assumptions about the best way to do the job based on his previous experience.
Uh-oh.
And ended up using screws that were too short.
That doesn't sound good.
The screws weren't long enough to properly anchor the unit.
Okay.
And when someone sat down, the entire unit ripped from the wall and they fell, injuring themselves.
Wow, that's a scary example of how assumptions and poor communication can really create dangerous situations.
Yeah. It highlights the importance of having clear, detailed instructions and making sure everyone involved understands the task.
Right.
And it also underscores the need for proper training and supervision, especially when dealing with something that could have structural implications.
Right, because even seemingly simple tasks can have hidden complexities.
And I imagine there are plenty of examples where these kinds of oversights have led to much more serious consequences.
Unfortunately, you're right. One that immediately comes to mind is the Texas City refinery disaster of 2005.
Okay, the Texas City refinery disaster. I remember hearing about that, but I don't recall the details.
Yeah.
Could you refresh my memory?
Sure. So this happened at a BP refinery in Texas.
Okay.
During a startup procedure, there was a massive explosion and fire that killed 15 people and injured over 180 others.
15 people. That's heartbreaking.
It was a horrific tragedy, and what makes it even more tragic is that it was entirely preventable.
So what went wrong?
Investigations revealed a cascade of failures, from equipment malfunctions to human errors and organizational failings.
Okay.
They had overloaded a distillation tower,
Uh-huh.
which then overheated and released a flammable vapor cloud.
So a series of mistakes and oversights ultimately led to this catastrophic event.
Yes. There were warning signs that were ignored, and the investigation found that cost-cutting and a lax safety culture at the refinery contributed to the disaster.
Wow. So even though they had some safety systems in place, the overall culture wasn't prioritizing safety, and that ultimately had devastating consequences.
That's a key takeaway here.
Yeah.
Safety isn't just about checklists and procedures. It needs to be embedded in the culture of an organization.
Right.
It needs to be a value, not just a set of rules.
That makes a lot of sense. You can have the best fire extinguisher in the world, but if nobody knows how to use it, or if they're too afraid to use it, it's not going to do much good.
Precisely. A strong safety culture empowers people to speak up when they see something wrong,
Right.
to ask questions and to prioritize safety over shortcuts or expediency.
Absolutely. And this brings us back to the human factor.
Yeah.
We can have the best technology and systems in the world,
Right.
but if people aren't following procedures, communicating effectively, and prioritizing safety, then accidents can still happen.
You've hit the nail on the head. It's a constant reminder that we need to be vigilant about the choices we make and the culture we create within our organizations and our own lives.
Okay, so we've talked about eliminating hazards, reducing them, putting safety devices and warnings in place.
Yeah.
But are there other strategies for building safety into our systems and processes? Especially when we can't completely eliminate those human factors.
There are, and one that's particularly effective is the concept of redundancy.
Okay, so redundancy. In a safety context, what does that mean?
Think of it like having a backup plan, a safety net for when things go wrong.
Oh.
It means having multiple systems or components that can perform the same function. So if one fails, the other can take over.
So it's like having a plan B, but for safety.
Exactly. And this principle is used extensively in industries where the consequences of failure are high.
Like in aviation?
Yes. Aircraft have multiple backup systems for critical functions.
Okay.
Things like navigation, communication, flight control.
Right.
So if one system fails, there's another one ready to step in and prevent a disaster.
So like having a co-pilot.
Exactly. It's the same principle with backup generators in buildings. If the power goes out, the backup generator kicks in to keep things running.
Okay, I'm starting to see how redundancy can really make a difference in preventing those big catastrophic failures.
Yeah.
But is there a catch to this? Does it just make everything more complex and expensive?
There are definitely cost and complexity considerations. But the key to effective redundancy is making sure those backup systems are independent of each other.
Independent.
Yeah.
I'm not sure I understand.
What I mean is you don't want a single point of failure that can take down both the primary and backup systems.
Okay.
Imagine if your backup generator is connected to the same fuel line as your main power supply.
Right.
If that fuel line gets damaged, both systems fail.
I see. So it's not just about having backups. It's about making sure those backups are designed to withstand the same problems that could take down the primary system.
Exactly. It's all about anticipating those potential failure points and designing systems that can handle them.
Okay, I get the importance of redundancy. But is there anything else we could do to make our systems more robust and less susceptible to those Murphy's Law moments?
There is, and that brings us to another key principle in hazard control, fail-safe design.
Fail-safe design. I like the sound of that. So what's the idea behind this?
It's all about making sure that even if a system fails, it defaults to a safe state.
Okay.
In other words, the failure itself doesn't create a hazard.
So it's not just about preventing failures. It's about controlling what happens when a failure occurs.
Precisely.
Yeah.
Think about a circuit breaker in your house. When it detects an overload, it trips and cuts off the power to prevent a fire.
Oh, yeah, that makes sense.
Right.
So instead of letting the system just keep running and potentially causing a fire, the circuit breaker fails in a way that's actually protective.
Exactly. That's fail-safe design in action.
Okay.
And we see it in many other applications, like emergency shutdown systems in factories or the dead man switch on a train, which applies the brakes if the operator becomes incapacitated.
Wow, those are some pretty powerful examples of how fail-safe design can save lives. But I'm curious, are there any cases where this principle wasn't applied effectively?
Unfortunately, yes. Case 9-5 in our source material describes a safety breach in air cargo due to a lack of redundancy in a weighing procedure.
Okay, what happened in this case?
An airline had a policy of weighing cargo twice before loading it onto a plane,
Okay.
which sounds like a good redundancy measure,
It does.
but they only used one set of scales.
Oh.
So when those scales malfunctioned, there was no backup system to catch the error, and the aircraft was loaded with more weight than it was certified to carry.
Wow, so their redundancy system wasn't actually redundant at all?
Exactly. They had the concept right, but the execution was flawed.
Right.
It highlights the importance of making sure those backup systems are truly independent and can function even if the primary system fails.
It's like having two fire exits, but they both lead to the same locked door.
That's a great analogy. It's a reminder that we need to think critically about our safety systems and make sure they're designed in a way that truly mitigates the risks.
Well, this has been a fascinating exploration of some key principles in hazard control. We've covered the hierarchy of controls, Murphy's Law redundancy, and fail-safe design. But before we wrap up this part of our discussion, I think there's one more crucial element we need to address: communication.
You're absolutely right. Communication is the thread that runs through all of these concepts.
Exactly. Whether it's poorly written instructions, a lack of awareness about safety procedures, or just a failure to communicate effectively between different teams or individuals.
Yeah,
Communication breakdowns can have serious consequences.
absolutely. Effective communication is essential at every stage of hazard control, from design and planning to implementation and operation.
So how can we ensure that communication is truly effective when it comes to safety?
Well, it starts with understanding the basic elements of communication.
All right.
We need to consider the sender, the receiver, the message itself, and the medium through which that message is conveyed.
Okay, break it down for me. Let's start with the sender. What makes a good sender in terms of safety communication?
The sender needs to have a clear understanding of the hazard, the risks involved, and the control measures in place.
Right.
They need to be able to communicate that information clearly, concisely, and in a way that's tailored to the audience.
Right. So it's about using language that people can understand.
Yeah.
And avoiding jargon or technical terms that might go over their heads.
Exactly. And it's also about being aware of the receiver's level of knowledge and experience.
Okay, so what about the receiver?
Yeah.
What makes a good receiver in a safety context?
A good receiver is someone who's actively listening, paying attention, and willing to ask questions to clarify anything they don't understand.
Okay.
They're also open to feedback and willing to adjust their behavior based on the information they receive.
So it's a two-way street. It's not just about the sender transmitting information.
Yeah.
It's about the receiver being engaged and making sure they understand the message.
Exactly. Communication is a collaborative process.
Okay, so we've got the sender and the receiver. What about the message itself? What makes for a good safety message?
A good safety message is clear, concise, and relevant to the task at hand. It uses plain language, avoids jargon, and is free from ambiguity.
Okay.
It should clearly state the hazard, the potential consequences, and the actions the receiver needs to take to stay safe.
So no beating around the bush. No sugarcoating.
Right.
Just straight to the point with clear instructions.
Precisely. And finally, we have the medium.
Okay, so this is about how the message is delivered, right?
Right. The medium can be anything from verbal instructions to written procedures, signs alarms, training videos. The possibilities are endless.
So it's about choosing the right tool for the job depending on the complexity of the message and who you're trying to reach.
Exactly.
Yeah.
If you're communicating a simple hazard, a sign might be sufficient, but for a complex safety procedure, you might need a combination of written instructions, diagrams, and hands-on training.
That makes sense. And it sounds like considering all these elements, the sender, the receiver, the message, and the medium can really go a long way in making safety communication more effective.
Absolutely. It's all about closing the loop, creating a shared understanding of the hazards and the controls that are in place to mitigate them.
Right.
And fostering a culture of open communication where people feel comfortable speaking up about safety concerns.
Well said. And of course, let's not forget about Murphy's Law, which reminds us that even with the best communication strategies, things can still go wrong.
Right. Human error is a fact of life, and systems can fail in unexpected ways.
It's not about being pessimistic. It's about being realistic and using that awareness to be more proactive about safety.
Exactly. It's about being prepared, having backup plans, communicating clearly, and fostering a culture where everyone feels empowered to prioritize safety.
I love that. So as we wrap up this part of our episode, I think it's safe to say that hazard control isn't just about hard hats and safety goggles. It's a multifaceted discipline that involves understanding human behavior, designing resilient systems, and communicating effectively.
Well said. It's something that we all have a role to play in, whether we're at work, at home, or out in the world.
Absolutely. And in part 2, we'll delve deeper into some specific examples of how these principles are applied in real-world settings and how we can all take steps to make our own lives a little bit safer.
I'm looking forward to it.
Me too.
Yeah.
So until next time, stay curious, stay safe, and keep those safety conversations going.
Stay safe out there.
Thanks, everyone.
Welcome back to Key Safety Talks.
You know, as we were talking about the Texas City refinery disaster and the importance of a strong safety culture, it made me think about something.
Okay.
Sometimes, even with the best intentions, hazards can creep into our lives in subtle ways. We might not even recognize them until it's too late.
That's a great point. It's like that saying, familiarity breeds contempt.
Right.
We can become so accustomed to our surroundings and routines that we start to overlook potential dangers.
Exactly. It's like that wobbly step on your porch you'd been meaning to fix for months, or that overloaded electrical outlet that's just begging for a spark.
Right.
We see these things every day, and they just become part of the background noise of our lives.
And that's where proactive hazard identification comes in. It's about actively looking for those potential dangers before they turn into accidents.
So how do we go about identifying hazards in our own lives? Is there a method to this madness?
There are actually several models and approaches that can help us systematically identify hazards.
Okay.
One that's commonly used is the 4Ms model.
4Ms. Okay,
Yeah.
lay it on me. What are they?
The 4Ms stand for man, media, machine, and management.
Okay.
It's a way of breaking down a situation or process to look for potential hazards related to each of these elements.
Okay, so man would refer to human factors, right?
Exactly.
Like errors, fatigue, inadequate training, those kinds of things.
Exactly. And then media refers to the materials and substances involved in the process.
Okay.
Think about hazardous chemicals, sharp objects, even just slippery surfaces, anything that could potentially cause harm.
Okay, that makes sense.
Okay.
And what about machine?
Machine encompasses all the equipment and tools involved. This could include anything from a simple hand tool to a complex piece of machinery. Are they well maintained? Are they being used properly? Are there any safeguards in place? These are the questions we'd be asking.
Okay, so we've got the people, the materials, and the equipment covered.
Uh-huh.
What about the last M, management?
Management refers to the organizational factors that can contribute to hazards,
Okay.
such as a lack of clear procedures, poor communication, or a culture that doesn't prioritize safety.
Right.
Remember, the Texas City refinery disaster was a stark reminder of how organizational failings can lead to tragedy.
Right. It's not just about having the right equipment and training. It's also about creating an environment where safety is truly valued and prioritized.
Exactly. And there's another model that can be helpful for hazard identification called the goal accomplishment model.
Okay, how does that one work?
This one identifies 9 factors that can contribute to hazards.
Okay.
People activities, equipment place, environment, social management regulations, time, and cost.
Okay, so it's a bit more comprehensive than the 4Ms model, but it's still about breaking things down into smaller categories to look for potential hazards.
Exactly. It helps you consider all the variables that might be at play.
Right.
For instance, the place category would prompt you to think about the physical layout of a space,
Okay.
while environment would encompass factors like lighting, temperature, and noise levels.
So by using these models, we can start to develop a more systematic approach to identifying hazards in our everyday lives. But once we've identified those hazards, what's the next step?
Well, that's where the hierarchy of controls comes back into play.
Okay.
Remember, it's all about choosing the most effective control measures based on the specific hazard we're dealing with.
Right. Eliminate, if possible, reduce if you can't eliminate, and then move down the hierarchy to safety devices, warnings, and procedures, PPE as needed.
Exactly. And it's important to remember that hazard control is an ongoing process. It's not just a one-time fix. We need to be constantly reevaluating our systems and processes to make sure they're still effective and that we're not introducing new hazards.
That's a great point. So as our lives change, our jobs change, our technology changes,
Right.
we need to be adaptable and keep that safety mindset front and center.
Absolutely.
But, as we've been talking about all these different strategies for hazard control, I can't help but wonder, what are some of the most common hazards that people face in their everyday lives?
That's a great question. It's interesting to look at the data on this.
Okay.
One of our sources actually cites a list of the most frequently cited OSHA violations in 2013.
OSHA violations. So these are like the safety hazards that are most commonly found in workplaces.
Exactly. And while this data is specific to workplaces, I think it provides some valuable insights into the types of hazards that people are exposed to on a regular basis.
Okay, so what were some of the top offenders on this list?
Well, number 1 on the list was fall protection, which isn't surprising given that falls are a leading cause of workplace injuries and fatalities.
Right, that makes sense. Falls can happen in so many different settings, from construction sites to ladders at home.
Absolutely. And the next few violations on the list were related to hazard communication scaffolding, respiratory protection, and electrical wiring methods.
So it seems like a lot of these common hazards have to do with working at heights, handling hazardous materials, and dealing with electrical equipment.
Exactly. And even though this data is from workplaces, these same hazards can also be found in our homes and communities.
That's true. We might not have OSHA inspectors coming to our homes, but it doesn't mean we're immune to these dangers.
Not at all. It's a good reminder to be aware of these common hazards and to take steps to protect ourselves and our loved ones.
Okay, so let's talk about some specific examples. What are some things that people can do to reduce their risk of falls at home?
Well, first and foremost, it's important to make sure that all stairways have handrails and that those handrails are securely fastened.
Right? That seems like a no-brainer,
Yeah.
but you'd be surprised how many staircases are missing handrails or have loose handrails.
It's true. And another important step is to keep walkways clear of clutter and to clean up spills immediately.
Yeah.
A wet floor or a stray toy can easily turn into a fall hazard.
Especially for older adults or
Yeah.
people with mobility issues,
Yeah.
those kinds of hazards can be particularly dangerous.
Absolutely. And if you're using a ladder, it's crucial to make sure it's the right height for the job and that it's placed on a stable level surface.
And never, ever stand on the top rung of a ladder.
No, never.
I've seen people do that. It makes me cringe every time.
I know, it's a recipe for disaster.
It is.
And speaking of ladders, it's important to make sure they're in good condition and haven't been damaged.
Right. A rusty or wobbly ladder is definitely not something you want to be climbing up on.
Absolutely. So those are just a few simple tips for preventing falls at home.
Great tips.
But what about some of these other hazards on the list, like handling hazardous materials?
Okay, so let's talk about hazardous materials.
Okay.
What are some common household products that people might not realize are actually dangerous?
Well, cleaning products are a big one.
Okay.
Many common household cleaners contain harsh chemicals that can be harmful if ingested, inhaled, or absorbed through the skin.
So it's important to always read the labels carefully and to store these products out of reach of children and pets.
Exactly. And when you're using these products, make sure you have good ventilation and wear gloves to protect your skin.
Right. And never, ever mix different cleaning products together.
That's a crucial point. Mixing chemicals can create toxic fumes or even cause explosions. It's just not worth the risk.
Okay, so cleaning products are definitely on the list of hazardous household materials. What else should people be aware of?
Pesticides are another big one.
Okay.
Insecticides, herbicides, rodent poisons. These are all designed to kill living things.
Right.
So they can obviously be harmful to humans as well.
So it's important to use these products sparingly and to follow the instructions carefully.
Exactly. And store them in their original containers out of reach of children and pets. And if you have any leftover pesticides, dispose of them properly according to local regulations.
Right. Don't just pour them down the drain or toss them in the trash.
Absolutely not. And another category of hazardous materials that people might not think about is paint and paint thinners.
Oh, yeah. Those fumes can be pretty intense.
Paint fumes contain volatile organic compounds, or VOCs, which can cause headaches, dizziness, and respiratory problems.
So good ventilation is key when you're painting.
Absolutely. Open windows, use fans, and if possible, wear a respirator mask to protect your lungs. And make sure you store paint and paint thinners properly to prevent spills and leaks.
Okay, so we've covered some of the most common hazards related to falls, hazardous materials, and electrical equipment. But I'm curious, are there any emerging hazards that people should be aware of, things that might not be on the radar yet?
That's a great question. And one thing that comes to mind is the increasing prevalence of nanomaterials.
Nanomaterials. Okay, I'm not familiar with those. What are they?
Nanomaterials are tiny particles that are engineered at the nanoscale,
Oh,
which is about 1 to 100 nanometers.
okay.
To give you a sense of scale, a human hair is about 80,000 nanometers wide.
Wow, so these things are incredibly small.
They are. And because of their size, they have unique properties that make them useful in a wide range of applications, from electronics to medicine to cosmetics.
Okay, so they're tiny and they have special properties, but what makes them potentially hazardous?
Well, because they're so small, they can easily be inhaled or absorbed through the skin. And once they're inside the body, they can interact with cells and tissues in ways that we don't fully understand yet.
So it's like a whole new frontier of potential hazards that we're just starting to learn about.
Exactly. And the research on the health effects of nanomaterials is still ongoing.
Okay.
But there's growing concern that some of these materials could pose risks to human health and the environment.
So it's important to stay informed about these emerging hazards and to take precautions when handling products that contain nanomaterials.
Absolutely. Always read the labels carefully and follow any safety recommendations provided by the manufacturer. And, this brings us back to the importance of effective communication.
Right. Manufacturers need to be transparent about the materials they're using in their products.
Yeah.
And consumers need to be educated about the potential risks.
Exactly. And I think this is where government agencies like OSHA and the EPA have a crucial role to play. They need to stay ahead of the curve on these emerging hazards and develop clear guidelines for safe handling and disposal.
Absolutely. So it seems like hazard control is a constantly evolving field.
It is.
As new technologies emerge and our understanding of risks evolves, we need to be adaptable and continue to refine our approaches to safety.
You've hit the nail on the head. It's a dynamic field that requires ongoing vigilance, innovation, and collaboration.
Well said.
Yeah.
So as we wrap up this segment of our discussion on hazard identification and control, I think it's clear that this is a topic that's relevant to all of us in every aspect of our lives.
Absolutely. It's about being aware of the potential dangers around us, taking proactive steps to mitigate those risks, and fostering a culture of safety in our homes, workplaces, and communities.
Well said. And in part 3 of our episode, we'll shift gears a bit and delve into some specific case studies that illustrate these principles in action. We'll also talk about how to apply these concepts to your own life to create a safer environment for yourself and those around you.
I'm looking forward to it.
Me too. See you soon for part 3. Welcome back to Key Safety Talks, everyone. We're on the final leg of our journey into the world of hazard control, and I'm really excited for this part because we're going to get into some real-world case studies that bring all these concepts to life.
Yeah, it's always good to kind of, see these principles in action.
Exactly. So which case study are we going to tackle first?
Well, let's revisit case 901.
Okay.
The one that gave birth to Murphy's Law itself.
Oh, yeah.
Captain Ed Murphy and the rocket sled experiment.
Ah, yes. The tale of the miswired sensors and the frustrated engineer. What are the key takeaways from this case in terms of hazard control?
Well, it really highlights how human factors can affect even the most carefully designed systems.
Right.
We can try to eliminate hazards or control them, but human error can still creep in.
And Murphy's corollaries really drive that point home.
Yeah.
Human judgment is not a sure thing.
Right.
Any system that depends on human reliability is unreliable. It's a good reminder that we're all human and mistakes happen.
Exactly. This case study also shows how important it is to have clear procedures and to make sure everyone understands them.
Right.
The technician who miswired the sensors was apparently following a procedure, but it wasn't clear enough to prevent that error.
So it's not just about having procedures, it's about making sure they're well written, easy to understand, and consistently followed.
Precisely. And having systems in place to catch those errors before they become accidents is also crucial.
Right.
In the rocket sled case, a system for double-checking the wiring could have caught that error and prevented the whole incident.
Right. That's a great point. It shows the value of redundancy, having those multiple layers of protection.
Absolutely. Now let's move on to a different case study.
Okay.
One that highlights the importance of clear communication. Case 9-2, the seating installation mishap.
Ah, yes. The case with the vague instructions and the installer making assumptions.
Right. This case is a classic example of how communication breakdowns can create hazardous situations.
Yeah.
The instructions given to the installer were unclear about how to attach the seating unit and what kind of fasteners to use.
Right. And that led to the installer using screws that were too short, ultimately resulting in someone falling and getting injured when the unit ripped from the wall.
That's it. This case is a reminder that communication is essential throughout any process, from a design to implementation. When instructions are unclear, assumptions are made,
Right.
or communication is lacking between different parties, the chances of errors and accidents increase significantly.
So communication is key, but it has to be effective communication.
Exactly. The person sending the message needs to be clear and concise. The person receiving it needs to pay attention and ask clarifying questions. And there needs to be a system to make sure everyone understands what's going on.
It sounds like a shared responsibility to keep things safe.
Absolutely. Now, let's examine a situation where a lack of redundancy led to a safety issue.
Okay.
This is case 9-5, the air cargo weighing incident.
Remind me what happened in this one.
An airline had a policy of weighing cargo twice before putting it on a plane,
Okay.
which seems like a good redundancy measure in principle.
It does, yeah.
But they were only using one set of scales.
Oh.
So when those scales malfunctioned, there was no backup to catch the error.
Okay.
And the aircraft was loaded with more weight than it was certified to carry.
Wow. So their redundancy system wasn't actually redundant at all.
You're right. They had the right idea, but the way it was set up was flawed.
Yeah.
It shows how important it is to make sure those backup systems are truly independent and not subject to the same problems that could affect the main system.
It's like having a spare tire in your car, but realizing it's also flat when you get a flat tire.
That's a great way to put it.
You know?
Redundancy is only effective if those redundant systems can step in when needed.
So we've covered a lot of ground here today.
We have.
We've explored these different case studies and seen how these hazard control principles can play out in the real world. But how can our listeners apply these principles to their own lives to make things safer for themselves and those around them?
That's the big question. And I think it all starts with awareness.
Okay.
Take a look around your everyday life with a critical eye.
Yeah.
What are the potential hazards?
Walk through your home, your workplace, think about your commute, and try to spot those things that could cause harm.
Exactly. Once you've identified those hazards, Think about the hierarchy of controls. Can you eliminate the hazard? If not, can you reduce it? Are there safety devices you can put in place?
And if those aren't options, think about warnings and procedures. How can you communicate the risks clearly and create guidelines for safe behavior?
Precisely. And don't forget about redundancy and fail-safe design. Think about important systems in your life, like your car, your home's electrical system, your smoke detectors.
Yeah.
Do they have backups? Are they designed to fail safely?
It's all about taking a proactive approach to safety and not waiting for something bad to happen before you act.
That's the key. And remember, safety is everyone's responsibility. We need to look out for each other, communicate openly, and create a culture where safety comes first.
Well said. So as we wrap up our deep dive into hazard control, I think it's clear that we can't eliminate all risks, but we can take steps to make our world a safer place.
Absolutely. But understanding these principles and putting them into practice, we can make a real difference.
Thank you for joining us on Key Safety Talks. We hope you found this episode informative and empowering. Until next time, stay safe out there.